Who can tell me what these are? Raise your hand and tell me what these are. Jonathan?
Pentominoes.
Think about the name pentominoes, and if you break it apart, where do you think they were able to get a name like pentominoes? Sirach?
They have 5 squares, and it says pentominoes, and that pent part means 5.
Ah, very good. My name is Nan Cepeda. I teach 5th grade at Arizona Fleming Elementary. We're located in the southwest part of Houston. Since these take 5 pieces, then if I said that I wanted to make them out of 6 pieces or 6 squares, then what could we call those?
Hexominoes?
Hexominoes, yeah. How many of you think there would be more shapes that would be in hexominoes than pentominoes? Anyone think there would be less? Okay. What I'm going to have you do is pull out the pentomino package that you have right there, and in your groups, I want you to separate them out for just a moment and look at all of the pieces. If you had all of the pentomino pieces together, then how could you put them in groups? What kind of characteristics would you be looking for? I'm going to give you about 3 to 5 minutes to talk in your group and find some more characteristics.
This has 4 angles. This has 6. 2, 3, 4, that's 6. 5, 6 on this side. This has 6 too. Put 6 on that side. 1, 2, 3, 4, 5, 6, 7, 11, this is 7. You can't count 12. Those are 9 angles. Those are right angles. Oh. Okay, I get it.
I started this lesson with pentominoes because the children were familiar with pentominoes and they knew how they were structured and they knew how they were put together. So since they were familiar with them, I could refer to that to get them to brainstorm about hexominoes.
Hey guys, there's the same number of sides as angles. See, this is 10 angles and 10 sides.
Well, what about this one? This has 12. What about this one? 1, 2, 3, 4, 5,
You already counted that one.
3, 4, 5,
Separate them by
6. Is this a 6 angle?
7, angles and
9, 10.
And what else?
10. No, this is 6 angle here, right?
How many? The amount of right
6.
angles.
That's 10.
And
10? 6. No, those are 6. These are 6.
I think we're ready to begin something, and I think you're going to like doing this. We know that pentominoes have 5 squares. So what we're going to do is make hexominoes. And you're going to make hexominoes out of the grid paper that's found in the baskets. And if you'll lift this up and look under it, you have grid paper inside of it. You have Scotch tape, you have scissors, you have a marker, and if you need the color tiles to remind you about what you need to move around to try to find the different shapes for hexominoes, you can do that. But what I want you to do is make as many hexominoes as you possibly can. Does anyone have any idea how many hexominoes there are? You want to take a guess?
about 100.
About 100, okay. What do you think, Lee?
About 60.
Okay, we kind of think that there are quite a few of them. You know, sometimes I tell you to organize information and to put it into categories. That's what I want you to do. And you can use the marker to draw it on this large piece of blue paper.
I need one more. When you have one, check to see if other people have it, and if not, trace it. Does anybody have this? No, not yet. Does anybody have this?
The rest of us will...
I'm going to need scotch. No, you can do it like that.
The most effective way to teach children is to put manipulatives in their hands. And I made them make their own. And when children make their own, they can remember a lot more. Now that you have quite a few hexominoes, I want you to take the hexominoes that you have and separate everything else that you have on your desk, put it inside of the bins, and set that on the floor. Take the blue paper, stretch it out on the dull side, and you have to come up with at least 2 to 3 things that make these hexominoes different by characteristics.
These are all symmetrical.
Symmetrical? Symmetrical.
How? Oh, I see.
That's symmetrical.
That's symmetrical.
Look, down the middle.
Yeah, that's right.
This is.
Hey, remember those trees we did?
That was symmetrical.
We start out with the symmetrical, then we split these up and put them in two groups.
So we do the tree thing.
Yeah,
See? And that splits up into two groups. How about two
That was
different
split up
kinds
into
by
two
right
groups.
angles? By right angles, but then there would be like a lot of possibilities.
How many,
So what are we doing this one?
1, 2, 3, 4, 5.
1, 2.
I guess we do the same thing.
Angles, so we're doing angles?
Yes. Try to separate them into groups. 5 or less, 6 or more. Try to separate them into groups.
This one has 4.
7.
What characteristic were you working on?
Angles.
At
Angles,
first
all
we
right.
had symmetrical. These are symmetrical.
Are you talking about the number of angles?
We don't, yeah, but
Yes.
Show me on here what you mean by angles.
okay, so 1, 2, 3, 4, 5, 6, and 7.
Okay, the number of angles on each of the shapes. Are they different?
Yes.
That's one I had not thought about, so wow, that's very good.
Dominoes. I've seen 3D dominoes.
Cool. But wouldn't there be too many variables?
There be 2 variables.
Here, give me some. It's too hard to figure out. Leave them flat. I don't know. Do you want to consider this an S?
Should we consider this an S?
No? Neither.
This could be an L.
That's an L. Well, that's uppercase.
Uppercase.
I had one group that came up with just the absolute shape, and there wasn't a whole lot of mathematics in what this one group was doing. But I didn't want to push them. I think that's the wrong thing to do, to push them and try to get them to do what you want to do. I wanted them to do what they wanted to do.
And this is would this be an lowercase L?
Yeah, that's the lowercase L.
Okay, which one's make cube?
Yeah, which one's?
Okay, this doesn't make a cube.
This one makes a cube, I guess. Yeah.
This one doesn't make a cube.
This one does not make a cube.
No, don't group back. That needs one more cube. Don't.
No.
This has one more side. I know, but it needs one more to make it. One more side to make it. Well, in our group, we tried to see which ones made cubes, and then which ones made cubes with one face missing, and which ones didn't make cubes at all, or 2 or more faces missing.
This one does.
I need 3 or 4.
This one does. This needs 2 more sides.
2 more sides. Okay, now let's draw the lines and stick it down.
Needs
Okay, why
one
don't
more
you
side to make a cube, more than one side to make a cube, and makes a cube.
Well, this is all tangled. Let's tape the cube. They don't work well on that. Let's tape the cube. Let's tape the cube like this. Why don't y'all just tape it down like this?
Okay.
So we can see the whole shape.
I need some tape.
Take some tape. Whoa. This needs one more side. Hey, I was just fixing to use the tape. That's not fair. Is that all that makes a cube?
Yeah.
Only 4.
Does this make a cube? This?
Yeah.
But this one's not symmetrical. You can cut it and tape it. Cut it, but then it wouldn't have 6. And tape it.
This does not fall into any other category.
We looked at each one, and my group decided what categories it should be in. Maybe we could just move these. We categorized it by perimeter, by length, how many squares are in the length, and by the line of symmetry. What we could do, we could cut this one off and put it right there so it's a different one. And this one, we could add it onto another. You could put it like right there. This one, scissors.
All right, I need to ask you another question. What kinds of things did you learn today?
I learned that even though when you're trying to make a cube, even though it has 6 faces, it doesn't make a full cube with 6 faces.
Very good. Anyone else? Chris?
Well, I learned that even though they have all of them have the same area, they don't have the same perimeter.
Oh, very good. That's one thing that I really wanted you to remember. Sarag?
There were more hexamenos than I thought there would be.
Oh. Do you think there are more to come that we
Yes.
haven't done yet?
There's some we haven't figured out.
I'm going to ask you to give me another prediction. I heard a lot of the predictions were like 70, 100, 120. I can't remember right offhand. But how many of you would like to change what you said a while ago? But we'll have to find that out tomorrow. Does anyone have any questions?
Is there like any way to find out how many combinations there are on the
That you
hexameter?
will have to find yourself. Can you think of a way that you might give people a hint so that when they come in tomorrow they would be able to do them a little bit quicker?
You can make like a grid, and then it could be this many different positions, and there's this many squares. You might be able to multiply them together.
Okay, so there might be some type of formula
Yeah.
or some type of pattern to it. Okay. I think the children were able to apply a lot of the things that they had learned in math, and when they started to make the hexamenos, they realized, oh, it's okay, we have 6 squares, and that's the area, and that's true on all, but the perimeter is different. And I didn't realize that that could happen, and you could see a lot of the eyes like, wow, that's really true, okay?
What is your role when a lesson goes in an unexpected direction? Discuss Ms. Cepeda's reaction to the group who sorted by letters. How else might you focus this lesson?